For problem 5.37, we have this table with several characteristics for 4 MOS transistors. And we know some of the characteristics, and other ones they're missing, and we need to define them based on the parameters that we know for each one. So in this case here, we want to define lambda, which is the channel modulation parameter, the early voltage, the drain current, and the output resistance. So to calculate lambda, so there's several equations that relate those quantities here. One of them is that lambda is equals to 1 over the early voltage, which basically means that the early voltage is equals to 1 over lambda. We also have an equation that gives us ID, so ID is equals to 1 over lambda output resistance, and which gives us R naught, or the output resistance, equals to 1 over the channel modulation parameter times the current. Okay, and don't forget that the quantities here are lambda, it's reciprocal voltage, the early voltage is volts, the current is in milliamps, and the resistance there in kilo ohms. Okay, so for the first transistor, okay, we have the early voltage and the drain current. So from the early voltage, okay, for the early voltage, we can calculate lambda, right? So lambda is going to be 1 over 20. And this gives us 0.05 reciprocal volts. And we also need to define R naught. So R naught, the output resistance, is going to be equals to 1 over, now lambda, we are using this equation here. So we know lambda 0.05 times the current, that is 0.5 times 10 to the minus 3. And this gives us 4 TK ohm. So this is for the first transistor. For the second one, we have the channel modulation parameter lambda, so we can calculate the early voltage, that is 1 over 0.02, right, using this equation up here. And this gives us an early voltage of 50 volts. The drain current is also missing, so for the drain current we can use this equation here because we know the output resistance and we know lambda. So ID is equals to 1 over 0.02 times 25 k ohms, and this is 2 milliamperes. So MOS 1 and 2, they are done. Now for the third transistor, we have the drain current, that's 0.1 milliamperes, and the output resistance, that's 100k ohms. So we can calculate lambda using this equation here because we know the drain current and the output resistance. So lambda is equals to 1 over ID, which is 0.1 10 to the minus 3, times the resistance, that is 100k 10 to the 3. This gives us a lambda 3. This is 1, 1, 2, 2. That is equals to 0.1 reciprocal volts. And the second parameter that we need to define is the early voltage. So if we know lambda 3, we also know the early voltage for the MOS 3. And that's 1 over 0.1, which gives us 10 volts. And for the fourth MOS, so let me go down here. We know the early voltage, so if we know the early voltage, we can calculate lambda 4. That's 1 over 100. And this gives us a channel modulation parameter that is 0.01 reciprocal volts. And we just need to define the drain current. So the drain current, we know the resistance, we know lambda, we can calculate the drain current. So in this case, ID4 is equals to 1 divided by 0.01 times 510 to 3, which gives us a drain current for the fourth MOS of 0.2 milliamps. And if we plug in all those values in a table, that's the result that we get.